here are some common tools. We have wire strippers, um, Wago connectors, Wago tool, side cutters. I don't know how to say that one. Which one? The ferrules. And that one.
Um, so we have the like the breaker bot thing, breaker,
The
that
break.
breaker.
Yeah, the breaker.
That um, see, this is what happens. My mind blanks when I do presentations. PDH, SparkMax, radio power module, VRM, Pigeon, and RSL. There's also like motors like Krakens, Neos.
So that was just some of like the basic tools and components that everybody should know if they're going to be working on electrical stuff. So now we're going to talk a little bit about wire management, organization, and troubleshooting. Something that we've been doing recently is we've been making a list of all of our CAN IDs and all of the PDH slots that each component plugs into. And when you make this list, make sure you keep it updated. What we've done is I just made the list in my notes app and then posted it to our base camp so everybody can have access to it, and it makes troubleshooting a lot easier because let's say you suspect there's a problem with a specific motor. You can go to the list and look at where that motor is plugged in and go and check that connection right away. We use a lot of zip ties. Um, so that's a big thing that helps with keeping stuff organized. We tend to we'll zip tie all the wires from one motor together. We'll zip tie different bundles. It makes things look a lot neater. And then something that we have just started doing recently is we've been making electrical drawings. So we'll do different drawings of our components and what the belly pan looks like so we know where all of our components are. And we do this mainly for organization, but it gives us a visual of where everything is, what is wired where, what is connected to each other, stuff like that. Anything you guys want to add? So electrical training is a pretty big thing, and as a sub team lead, one of the best things I've found is that getting people hands on as early as possible makes things go a lot smoother because it helps familiarize all of the new members with all the different components and just gets them comfortable working with all the electronics and gets them comfortable doing wiring. And the main reason I think that this is pretty important is because a lot of times people are, I guess, scared to work on the robot at first because I mean it's intimidating, but the sooner you can get them hands on, the sooner you can get them comfortable with stuff like that. And then we've done electrical training a couple different ways. The first one is we built an off-season robot this past off-season, and a lot of the wiring was done by Vivian over here. And that was a very good way to train without it being super high pressure. You want to talk a little bit about that? Okay. And then not this past summer, but the summer before, we made what was essentially just a tiny robot. And its sole purpose was for programming training, electrical training, mechanical training, all of it. and it was a significantly less intimidating way to get people working on a robot. And then this year, something that we did for the first time was when we had our first meeting with all of our new members, is we did these sub-team rotations where each sub-team had its own station. And at the electrical station, we kind of just went through all of the basic components and basic wiring stuff. I used our off-season robot as the main example and disconnected a couple wires, had the students reconnect it. Just simple things like that are good ways to get training started. And then with the season starting, it usually takes a bit of time for electrical to actually get the robot and be able to start wiring. So there's a couple things you can be doing in that time while you're waiting for the robot. And the biggest one is to make sure you have a plan. Talk with the CAD people and the mechanical people on your team and make sure that with whatever they're planning, you'll have space for the electronics you need, and just look at the designs, kind of come up with a general plan from there, and start assigning like CAN IDs and PDH slots and stuff like that to all of your motors. Taking inventory is a big one. We usually do this before the season starts, but just making sure you have everything you need before you get the robot. Because if you don't have that stuff when you get the robot, there will be a pretty big delay in getting started, and nobody wants that. And then training, just the biggest thing is making sure that the new people on the team are comfortable and feel somewhat ready to work on the robot when the time comes. I think that's it. Does anyone have any questions?
What is one of your favorite electrical products to start?
Can you repeat the question?
I think so. One of my favorite electrical.
What's like one of your favorite things that you've done, like with the robot, or something that you continue to do with the robot?
Honestly, I really enjoyed wiring our off-season robot because just the way that we wired and organized it, it looks way nicer than our main robot does, organization-wise. What about you, Preston?
What about me?
Answer the question.
Um,
You don't have anything?
no, my mind's blanking.
Yeah, wiring the off-season robot was just a lot of fun. I got some new experience with working on electrical team because I've never done Lego League or any of that, so this is my first year working with the program, and it was really good to get some experience.
Any other questions? Okay. I think that's all we have. Yeah.
So I know you guys talked about like drawing right? What do you guys use? Do you guys just like do it on paper? Do you use some type of like resource?
So we use AutoCAD to do our electrical drawings, and this is something we just started doing fairly recently, so we're all still trying to like familiarize ourselves with the program and figure out exactly how we want to do it. But we have drawings of like our PDH and all of the wires that go into there labeled with like what motor they're from. and we have a couple other components drawn just for like visual representation. And right now we're working on a drawing of the belly pan from last year's robot to also kind of just serve as a visual for where everything is. Anything else? Yeah, that's all we have. So, yeah.
Do you have any interesting stories about breaking electronics that you can learn from?
We do have a couple. This past season, it was, I think, when was it? Yeah, but when during the season was it? Yeah, it was between weeks 1 and 3. We were working on our robot. We were just fine tuning some stuff, and we had just changed a mechanism, so we were working on all of that, and we had one of our swerve modules catch on fire.
It wasn't any mistake by us, it's because of the new work. What do they call them? Yeah,
Yeah.
vortexes, the part underneath it shorted it out, so it's like a little fire, and you're like, oh, it smells, where did that come from? And you're like, oh, look, a little flame.
Most of us didn't even see it. It was like gone in 2 seconds.
But, yeah, there was nothing that we did wrong, it was just a false part. So, big one. I think that was the whole big one for
Yeah, that's the only like major electrical issue I've really witnessed.
Like, would you describe it as majorly impacting how like we go about checks or anything, or like making sure we're not shorting the frame or
Yeah, I would think so. I think we definitely paid a lot more attention to it, like especially during inspection at our next event, and it was something that we continuously kept an eye on because after that happened, we switched to the regular back to the regular Neos, and before it was either before our third competition or before we went to Houston for champs, we decided that it was okay to switch back to the vortexes, but we had to keep an eye on it throughout the season and make sure that issue didn't come up again. Yeah.
They're all hard-learned lessons from practical experience, but the three things I would recommend are: one, tell your safety folks that you want a non-dry chemical fire extinguisher, because you spray a dry chemical fire extinguisher in the robot, it's hard to clean out and it's corrosive. Before you power your robot up after you've wired it, you should do that grounding check to the frame that was mentioned. And the right way to do that is to close the main breaker and take the meter and measure from both terminals of where you plug the battery in to your frame parts. Not just from one side, close the breaker and measure both sides. That's how we tell the inspectors to do it at the event. So that's how you want to make sure you're checking it. We have seen a lot of cases in the last few years where some of the older brushed motors have developed shorts in them to the case. So that's one to check. And the other one is most of these electronics are very allergic to being plugged in backwards. So double check your polarities and make sure everything's red to red, black to black. And then we were working on our robot last week, and I went to plug in a motor controller, somebody handed me, and the plug was assembled backwards. So double check all of that before you turn the robot on. And all of the electronics are also very allergic to metal share.
Anything else anyone wants to add? I think we're done.
Okay.